All right, let's look at part B. We have x equals 4 cosine t and y equals 2 sine t, and t interval is specifically prescribed for us. And cosine and sine are 2 pi periodic functions, so we're talking about the one period corresponding to this. Okay, so let's go ahead and look at dx, dy over dx. Okay, so dy over dx, and this is with the formula dy over dt divided by dx over dt. Okay. Let's take the individual derivatives here. So 2 cosine t minus 4 sine t. So that this becomes negative 1/2 cotangent t, because cosine t over sine t is cotangent. Okay. So now let's look at d squared y over dx squared. And again, by using the formula, so this is the t derivative of dy over dx divided by dx over dt. Okay. All right, go ahead and look at the derivative of cotan t at the top. That's cosecant minus cosecant squared t. So that makes it 1/2 cosecant squared over t. And still I have dx over dt to be negative 4 sine t. And now we can use a definition of cosecant squared t. That's 1 over sine squared t. So in total, all in all, you have sine cube t at the bottom. Okay. So right now we should look at the sine of d squared y over dx squared, and to do that, by the way, we have to look at what makes the bottom 0. Okay, almost like critical points discussion that we had in Calc 1. All right. So first of all, it's sine cube t. So if sine t equals 0, obviously the bottom becomes 0 and the whole d squared y over dx squared blows up. And go ahead and look for the t values coming out of this interval, making sine function 0. And if you use arcsine 0, you only get 0. You're going to miss all other points, okay? So go ahead and convince yourself that at t equals 0, pi, and 2 pi, you have sine exactly equal to 0. Okay? So that means I have two intervals to consider. One is 0, t, and pi, and the other one is pi, t, and 2 pi. Okay? All right, so first of all, before we jump into the sine of d squared y over dx squared, I want to know what the sign of sine is on these intervals. Okay, so first of all, sine t for t's from 0 to pi. So if you look at the unit circle, sines are the y values. So in the first and the second quadrant, sines are positive. So I'm going to say that this is all positive, okay? And for the t values in between pi and 2 pi, you're in the third and the fourth quadrant. So sine is supposed to be negative over there, okay? By using the same strategy, so we can determine the sine of the second derivative on these intervals, okay? So d squared y over dx squared on the first interval, let me also erase this so we can have more space down here, okay? On the first interval, okay, 0, t, and pi, t, and 2 pi. Okay? So d squared y over dx squared, I think that had the description of 1 over 8 sine cube t. Okay. So now let's check. Sine t is positive on the interval 0 and pi. So is sine cube of t, as you see, right? So this is going to be positive. So overall, you have negative 1 over 8 and a positive number. So it's going to take you to a negative number. Okay. And for t's in between pi and 2 pi, sine is negative, so sine cube is negative. And you have another negative 1 over 8, so that makes it positive. Okay, that makes d squared y over dx squared positive. And we know from Calc 1 that if the sine of d squared y over dx squared is negative, then you have concave down. And if it's positive, you have concave up. Okay, concave up behavior. So what I want to do now is to observe that from the graph of the equation here. So go ahead and please graph 4 cosine t and 2 sine t for x and y, respectively, for the interval 0 and 2 pi. And you should probably get a good ellipse like this. Okay. And let's see what t equals 0 corresponding to. So t equals 0 means you have 4 and 0. So you are right at this point, okay? So you're right at this point. For t equals pi, you have x to be negative 4 and y to be 0. And you're right at this point, okay? Right at the point that I just crossed. And for this is t equals 0, t equals pi, and at t equals 2 pi, you get back to where you start. Okay, so it's 4 and 0 again, and you can see the direction here. And this is one period. And I can visually observe that for t's in between 0 and pi, you're right about the x-axis, and it's concave down for sure. Right, this is concave down behavior, and for the t's in between pi and 2 pi, you're below the x-axis, and that's a concave up behavior. Okay, so our analysis done here is proving what we have done is true by looking at the graph of the function. Right. All right, so this is the end of the video. Thanks for watching. I'll see you in another video. Bye.